So the next question is reverse first k of a q. So basically in the question we will be given with a q, and on a q only these 4 operations are allowed, right? So we can insert an item with this nq operation where the item that is provided x, that will be inserted at the rear end of the queue. So at the back we can insert an item of this queue. We cannot insert at the front or anywhere in the middle, right? For the dequeue operation we can remove the x from the front of the queue. So whenever we will be deleting, it is the first element that will be deleted, right? And we cannot delete any of the middle elements or from the end. So these two things are the restrictions that are applied. This is the normal restrictions that are applied on a queue, otherwise it will be an array only, right? So if suppose this queue is given to us and we can only insert from the back and delete from the starting, these are the operations that are allowed, and we have to output this particular queue over here. This is also a queue which we need to return, and over there a k integer will be given to us. The first k integers will be reversed and the rest of the elements will be as it is. They will be reversed and rest of the elements will be as it is, right? I hope this is clear. The problem statement is, I think, clear. So now obviously if you try to do it in place, guys, you are only allowed 2 operations, right? Suppose you are allowed 2 operations. There is 1, 2, 3, 4, 5 that is given to us, and what you can do is you can remove the element from the starting, right? And suppose you put it in the back. Okay, so I can put it in the back after that, right? After that I remove this 2 over here and I put it in the back. After that I remove this 3 and put it in the back. So you see, you are now getting close to the result, because if you just perform normal removal operations from the starting and just keep on putting that particular item in the back, then whatever the order was, that order is maintained only. The earlier it was 1, 2, 3, again 1, 2, 3 only came in the back. I want to reverse this particular thing, right? So this particular observation will come handy, that if you just remove from the start and put it at the back, the normal order will be maintained, right? So but we need something else. So what I am saying is, let us take some extra space. Suppose I am taking a k size array. Okay, I am taking a k size array over here, and there we store all the contents. Suppose the first k elements are 1, 2, 3, right? And we pop them one by one and put them in the array. So after popping 3 elements, my queue will be having 4 and 5 only, because the earlier elements were popped, right? So after we do this, what we can do is, I can start iterating from the back of this array and start inserting it in the queue, and obviously insertion is done in the rear end. So 4, 5 is there. After that we insert 3, then we insert 2, then we insert 1. So this part is done. This part is done, for example. Wait for it, guys, I'll enhance the thing. After that, what is there? We are getting this 3, 2, 1 I am getting, but this 4, 5 came to back. And just now over here in this portion over here, we saw that if we just remove these 2 elements and put it at the back, the same order will be maintained. And if we just put them in the back, you see that this is our result array. This is the result queue that we need to return, right? So let us now focus on this array over here. What we did, we removed the first element, put it over here. Then we removed the second, put it over here. Removed the third, put it over here. So we removed and put the elements for k number of times. After that, I removed the last element, put it in the queue. Then removed the second last element, put it in the queue. Then removed one and put it in the queue. Now guys, if you look closely, this was the first element to get into this data structure, right? And this was the last element to come out. First in, last out. And always this is happening. This was the first, this was the second, this was the third. And this was again the first, this was second, this was the third. So the element that got in first was the last to leave. So this is nothing but a stack. We should not take an array. A stack is sufficient to do our job. We are always looking for the topmost position. We are inserting at the top position, right? And we are also removing from the top position. So instead of this array, we can take a stack. So this was the whole intuition about it. This is a GFG easy only. So basically what we did was, to sum it up, we took a stack and then we popped the k elements and put it in the stack. It came like that, and the remaining queue was something like 4 and 5, right? And in this queue, then we started popping from the stack and putting the elements, right? This was the queue 4 5 3 2 1. So after this 4 5 2 3 1 was there, we need to remove this element, put it at the back, remove the element, put it at the back, in order to sorry, it was 3 2 1, right? So this would have been like that. I hope the thing is clear, guys. So obviously simple coding, I'll code it up. I will highly recommend you to try it on your end, right? And before starting the code, over here it is also another thing is said that if the size of the queue is smaller than the given k, so there might be a possibility wherever the size of the queue that is given, the k is greater than it. In that cases, we should return the original queue. Let us now start with the code. I'll first take the size int n equals to my queue dot size, right? And after that, I will check if my n is if my n is less than k, then I will just return the original queue from here, right? As simple as that. This was our base condition. After that, we should create this stack over here that we will use for storing the first k elements, right? After that, I run a loop for k times ki plus plus, and I remove the first k elements from the queue and put it in the stack. So I will push certain thing in the stack, and what is that? Queue dot poll. This is the function to remove the element from a queue, right? So I push after popping from the stack, and I do it for k times, as simple as that. And then what I'll do, I will again iterate for k times, and then I will basically push all the elements from the stack to the queue. So basically my queue dot add, I will add what? Stack dot pop. I'm removing from the stack and adding it to the queue. So after these two iterations, basically what will happen, I have started with what? I have started with 1 2 3 4 5, right? After this, there will be a queue. After this first iteration over here, my queue will contain what? 4 and 5, and my stack will contain what? 3 2 and 1, right? Where top is this first position over here. After that, this loop will run and it will remove the elements and put it at the back of the queue. So what will happen after this iteration is 4 5, then 3 2 and 1. This will be the thing. After that, what I need to do for the rest of the elements, which is basically n minus k, for the n minus k elements, I should remove them from the starting and put it at the back of the queue. So I will iterate one more time, this time for I should be less than n minus k times, right? And I should increment. After that, what I'll do, I will add it to the queue. I will add what to the queue? After I remove it from the starting, I'll remove the element from the start and I will add that particular element at the back for n minus k elements. Then this 4 and 5 will come back basically. So after this, my queue will become 3 2 1 and then 4 and 5, right? And this is our answer. So I should return this particular thing. I should return this queue, right? I have used this stack. So the space complexity at any point, the stack is holding a maximum of k elements. So the space complexity is order of k. So guys, there was a internet issue. So I'll just compile the code. I have not changed anything. What I was telling is that the space complexity is obviously order of k, because at any given point of time, our stack can hold a maximum of k elements because we are pushing k elements only. And the time complexity is order of 2k plus n minus k, which is basically order of n plus k, right? And obviously that is order of n only, because k is smaller than n. I can tell order of 2n, or it is in order of n only, and the space complexity is order of k, right? So that's it, guys. Thank you.